In this video, we're going to learn about Charles's law. Charles's law is used to explain why it is that hot air balloons rise, and also why it is that footballs might deflate in the cold. It relates the volume and temperature of a gas, and those two variables are directly proportional. So let's say that we have a sample of gas at a certain temperature in, say, a hot air balloon. Well, if we raise the temperature, we cause the gas to get hotter. The volume of the gas will expand. And that's why a hot air balloon will float. Its density, the density of the air inside the balloon, ends up being less than the density of the air outside, and it floats. But if we inflate a football at room temperature to a certain volume, and then you go outside with that ball on a cold winter day during a playoff game, well, as the temperature of the gas inside the ball decreases, the volume also of that gas will decrease as well. Let's look at things at the particle level and understand a sort of kinetic molecular theory way of looking at things. So, temperature is average kinetic energy, and for a sample of gas, essentially, if you are raising the temperature, all you're really doing is making the particles move around faster. And so, if you have a case where the walls of the container are flexible, like in, say, a balloon, the pressure will roughly remain constant. And that's what we're seeing here. If there is a piston and the gas inside the piston is heated up, well, then the piston plunger will move up as the gas particles expand, as they're moving faster. Let's have a look at a simulation that involves these variables of temperature and volume at play. What we can see here is a piston with constant pressure. And I say constant pressure because there has to be some pressure. If there were no pressure, then the gas particles would just continually expand forever. But right now, what we can say is that we're at an equilibrium where whatever the pressure is pushing inward by whatever gas is on this side is equaled out by the pressure of the gas particles inside pushing out. Now, as we take this temperature of this gas and raise it, the gas volume will go from, say, around 0.5, whatever the units are, to, well, something bigger. It will proportionally increase. What's happening is that these particles are pushing harder and harder against the container, and they're causing that flexible wall to push outward. If this wall were not flexible, we would see an increased pressure. However, in this case, because it's a flexible container or a flexible wall, the pressure does remain constant. But in order to avoid pressure rising, the following needs to happen. Number one, the rate of collisions needs to remain pretty much the same. And if particles are moving faster, that means that there needs to be a bit more space between the particles and the container walls as these particles are moving faster. Also, the surface area for the particles to hit, that also should get bigger. And if that happens, then we can cause the pressure to remain constant, right? The force per surface area is not rising. However, in order for that to occur, the volume of the container must increase. And so that explains Charles's law. Hope this video has helped. Feel free to leave any questions or comments in the comments section below. Thanks for watching.